Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, our first question is 13 over 1,000. Just think about your place value grid, units, tenths, hundreds, thousandths. That 3 is over the thousandths column. Centimeters to millimeters has that 10 connection. So we're going to be timesing through by 10 to get 64. How many vertices does the cuboid have? Well, vertices are the corners, and there are 8 corners on that 3D shape. Just use your calculator for this one. They're really just testing if you know how to use the buttons on your calculator with a question like that. Okay, we need to complete the table. We can see that this is going up in 2s. So we've got 8 and 10. How many triangles are needed for pattern number 12? Well, you could just continue the pattern to work that out, or you could spot that actually these are just doubling. So pattern number 2's doubled, pattern number 3 doubled to get the number of triangles. So 12 times 2 is 24. And part C, Luke says that pattern number 40 has 82 triangles and you have to explain why he's wrong. Well, if you had spotted the doubling to help you answer B, that is actually what they're looking for to answer C. The pattern number is doubled, so it would be 80. Okay, question number 6 is a question we cannot answer because we haven't been given enough information. Janet sends parcels. What weights, how many, etc., etc. They haven't actually given us that information, so it's a question that we cannot answer. My only explanation for this is it is a practice paper, and maybe EDEXCEL don't go through quite the same rigorous sort of testing and checking of the papers. It's the only explanation for that to be missing, really. So unfortunately, we are unable to do this question. Okay, so to draw an accurate diagram of the sketch that they've given us, we are going to need to use a protractor. I have made a protractor. It's not brilliant, but it's perfect for me to at least demonstrate how you would pull this together, because unfortunately my software doesn't quite work. I haven't got a transparent protractor that I can use, so kind of this is the next best option. So the first thing that we're going to do is draw an 8 centimeter straight line with our ruler. I would label as I go, just so I know that I've done everything I can possibly do for that question. I would then take my protractor, and this part of my protractor where it crosses here is what goes on the end of the line here. Once you've got it in place, you can mark off where your 50 degrees is and then draw your line through. So this is my line going through the 50. Now, the reason that I've got a second one is because this is just a hand drawn. So when I pick it up and move it, I'll move the lines as well, which is a bit frustrating. But what you'll do is you will put your protractor on the end of the other line, and then you'll measure your 50 again. Make sure you are using the right scales each time. So just follow the 0 so it doesn't go wrong. And you'll see why I've drawn massive long lengths now. We don't know the lengths, so we can't draw an exact line. So, oops. So you draw them extra long, they will cross at the right place, and there's your triangle. Don't rub these out. These are your construction marks. These kind of almost prove that you were doing it the right way. Okay, so on our probability scale, we're going to mark with a cross and label with these letters the different events that they're describing. So the first one, you will have something to drink tomorrow, okay? Everybody drinks during the day, so the expectation is a certainty on this one. So we have got A. A teacher chosen at random was born on a Monday. Now, you have got a 1 out of 7 chance to be born on a Monday. So how do we get a 7th marked on this line? Best way is to measure it, divide it through by 7, and then that way you will get the measurement on your ruler. So it would be about here. And then a fair 6-sided dice showing an even number when thrown is half. It's evens. Find the median from a stem and leaf. It's the same as when you're doing it from a list and you've got to just keep crossing off evenly either end until you get to the middle. So we're going to do that. So you do the first number and the last number, the next number and the next, and you come in. Now, because there's quite a lot, I tend to do a chunk. So I'll go 1, 2, 3, 4, back 1, 2, 3, 4. I'll do another couple back. I'll do another couple forward until I get really close where I might go back to ones, and the answer is 30. So we've got different bulbs and the percentages. We've got to work out X. That's got to add up to 100%. So you're going to add up what they've given you, which will give you a total of 77. Take that away from the 100, and you've got your 23. Okay, so the area of land used to grow bulbs for hyacinths is 12,000 hectares. Now that is a fact. You might not spot that immediately, but it is a fact. And even if you didn't spot it as a fact, you'd probably write that information down next to each other. So I know that 8% is worth 12,000, might do a little arrow, however you set it up. We're then having to work out the land used for the daffodils. Now the daffodils is 12. If we line this up, so we have like a percent and an area column, we've got these 3 pieces of information. So this is my infamous boxes and labels. You don't have to put this grid on. I'm just showing how it kind of works. When you've got 3 pieces of information like that, and one of them has come from a fact where they are side by side, you can simply multiply it across that diagonal and divide by that one trapped in the corner. It's a calculator paper, so there's no reason to try and overcomplicate this. That's the maths. Throw it in, and that's your answer. Okay, we've got 1 suite of each of the colours. Barbara's going to take 2 randomly from the tube, and we have to write down all the possible combinations. So let's say she took a red first. She could have taken a blue next, or she could have gone red green, red yellow, or red pink. And then you just repeat that. If she took a blue, we've already got the blue and red combination, so we're just going to keep going forward. Blue green, blue yellow, blue pink. Now let's say she took a green first. That would go yellow, green, pink. And then you're left with just your yellow going with pink. Pink's been already selected, so don't repeat. If you write them back to front, that's not a different combination, so don't be tempted to do that. What is the probability that Barbara takes a red and a yellow? Well, that's 1 out of the total that is there, which is 10. Okay, Ali takes his car to a garage. The car has a 5,000-mile service, so that cost there, and has an MOT, so that cost there. And we've got to work out his total bill. Well, his total for the 2 items, 79 plus 39, is 118. And then we can see that this is an increase at 20%. It passes that 2-tick test. So we're going to use the original times multiplier equals result. We've got to work out our multiplier first. It's a 20% increase. So we're going to do 100% plus 20, which is 120. Now that's a percentage. We want the decimal version, so we divide through by 100. You can do all of this on your calculator. Calculator's going to tell you it's 1.2. The original is 118. Times that through, and you've got your answer. It's not the only way to do it, but the more we can spot this formula and use it, the more confident we'll become using that formula. So Ali bought his car for 20,000. The car depreciated 20% in the first and 10% in the second. Now, you mustn't get tempted to combine these percentages. When they give a problem with 2 different percentages, you've just got 2 different steps and you can't take a shortcut. Depreciate means we've got a decrease. So it's original times multiplier again. To do a decrease, you take away the percentage in the question. And as always, you divide through by 100. So the calculator will tell you it is 0.8. So 20,000 is the original, times it through, and you get its value after the first year. Take that, times it through this time by a 10% decrease, which is 0.9, and you get 14400, and that's your final answer. Okay, the diagram shows a prism, and in the space we want to sketch the front elevation from the direction marked with the arrow. So this here is actually our front elevation. There is no more to it. Imagine just kind of pushing against the shape and crushing it into its backside, or crushing it against a wall. This is going to fall exactly on top of this. There's nothing sticking out that I need to consider. So it's not anything more than drawing the trapezium. Becky says when you square a prime number, you always get an odd number. You've got to write an example to show this is wrong. So there is an example out there. Probably the easiest way to do it is to start with 1 and work your way through until you find it with your calculator. You may know straight away that it would be the 2 because that's our even number, and 2 times 2 is 4, and that shows nice and clearly. When you cube any negative number, you get a negative number. So cubing is multiplying a number by itself 3 times. So that would be multiplying a negative number 3 times. Now, if we look at the first 2, when they get multiplied together, they will create a positive number, but you've still got that times by another neg, and a pos and a neg even makes a negative number, and that's it, that proves it. So we've got blue, red and green counters in a bag. We've got some information to digest, and the question wants us to write down the ratio of the number of blue to the number of red to the number of green. So I'm going to get that down first, and then I'm just going to read the first line. there are twice as many blue counters as there are red. So let's just say there is one red. That would mean that there are two blue. When I read the second one, there are 3 times as many red as there are green. This isn't going to work anymore. So I'm going to abandon my original thought and think about the green being 1. And then 1 times 3 gives me 3 for the red, and then that ticks this one. And then I can go back. Twice as many blue means I'm going to times my red by 2 to give me 6. And that is my final ratio. And this type of thing is normal in maths. You're going to go to sometimes down a road that doesn't actually quite work out. And it's the way this has been worded really encourages this type of thing. We're not going to try and make this good. We're going to restart because we've now got a little bit more information and realized we needed to do it the other way round. Okay, without doing the exact calculation. So it's really important you do not do the exact calculation or you will get no marks. You have to explain why the answer cannot be correct. There's 2 possibly good answers here. You've got different denominators being added. If you don't get the denominators the same, you won't get the correct result. So we can comment on that straight away. You may notice that the 2 fractions are both over a half in their value, which means our answer would have to be over 1. And that would be another really good way of describing it. All right, we need to work out the size of angle X, and we must give reasons. I always recommend we do those reasons as we go. So X is here. If I had this angle, I would be able to use angles on a straight line, but I don't have this angle. If I had this angle, I would be able to use the triangle here to help me find this one. So this is where I'm going to start. I'm going to find this one. If you've got an angles question and you have absolutely no idea where to start, literally just do whatever you can see. I can almost guarantee it will be the right first step. So this is angles around a point. 360, take away 250, gives me 110. Mark it on. Write down your reason. Now I can work on this one. So I've added these 2, taken it away from 180 because we've got angles in a triangle. And then last but not least, we've got our angles on a straight line to finish us off. Okay, we're going to be drawing the graph of y equals 2x minus 3. Now, I strongly, strongly urge you to learn how to use your calculator for this. If it's on a calculator paper, you don't want to be putting all that work in that you would have to do by hand. We don't have a table for our coordinates, and you won't really need to do this if you're using your calculator, but if you're doing it by hand, you would need a table. You would then work out your coordinates. Again, if you're doing it by hand, you're going to be doing 2 times whatever x is, take away 3. So let's do this one on the end. We'd be doing 2 times 3 minus 3. This would give us 3. The rest of our coordinates can either be worked out by hand or, as I say, please, please learn to use your calculator for this type of thing. Now, unusually, we don't have the grid already set up for us, and that is unusual. In all the sort of last few years, they have been there. But if it's not, just consider what you've got to do. You've got a range of -2 to 3 for your x-axis, and then you've got to make sure you've got -7 as your absolute lowest, and then you've got your 3. So I'm going to get my axes set up first of all. Okay, so you can see that I've numbered my x-axes. I've done equal gaps of 2. Really important that if you're going to do gaps that's more than 1 square, you make sure they're even. If you only had 1 and then started going 2, it would be wrong. I've chosen to go up in 1s for my y-axis, and I've also chosen to be incredibly lazy and not label them all, which is fine. You then plot your coordinates. So we have got 3, 3, which for me is here. And then we've got 2, 1, and we would just keep going. Draw your line through, and we are done. Please don't forget to draw that line. It's one of the most common things I see. People have plotted everything perfectly and then they lose a mark because they didn't actually draw the line. Okay, so we've been given information about the water in a water container and how many cups it will fill. And we've got to explain why it's 92 cups at most. So we're going to take our 19.5 litres and we're going to multiply that through by 1,000 to just get our units the same. Now we're going to divide by 210 by the amount a cup will hold. And we get this on our calculator. That shows us that we can get 92 cups and a bit left over. 0.8571 isn't enough to fill the next cup. Now, that's not the only approach. These problem-solving style questions can generally be done in more than one way. I'm just demonstrating one way. Okay, so we're being told that the total cost of 3 apples and 4 pears is £1.84, and then we've got more information about a different combination. Now, this is a sneaky simultaneous equation. It's just been given to you in words instead of in the normal format that you are used to. So what we've got are 3 apples plus 4 pears equaling £1.84, and we've got 5 apples plus 2 pears equaling £1.76. And when you see it written like that, you can see the simultaneous equations. Now, don't be put off by the decimals. You've got a calculator. So as long as you're really confident with your method, you just step through in the normal way. Now, if you're one of my students, you'll know that I'm always saying just get these the same. 95% of the time, that is going to be easier in the long run. So I am going to multiply the top one by 5, the bottom one by 3. We're going to multiply all the terms and get equivalent equations to work on. Once I've done that, I am going to be taking away my A's from each other, my P's from each other, and my numbers from each other. Now, 15A take 15A means the A's have gone. That's the point of the method. We don't really want to be trying to work out 2 different letters at the same time. So my A's have vanished. I've now got 20P take 6P, which is 14P. That equals £3.92. I'm going to divide through by my 14 and work out that P is equal to 0.28 or 28 pence, because they do want our final answer in pence. Now I know my P, I can work out my A. I need to choose one of these. I think I'm going to go for this one. So I've got 5A plus 2P equaling £1.76. This is going to be 2 times 0.28. I'm going to use my decimal answer because I'm still working within these calculations. So this is going to give me 5A plus 0.56 equaling £1.76. And now I will just go on and solve. I'm going to take this across. It lands is take away 0.56. So 5A is equal to 1.2. Divide through by the 5, and A is equal to 0.24 or 24 pence for the answer line. So we've got red and blue counters in a box. There are 3 times as many red counters as there are blue counters. Carl is going to take 1/3 of the red counters. Kerry takes 80% of the blue, and we've got to work out the ratio of the number that are left in the box. So the first thing we really need to do is get our ratios together on this one. We've got just red and blue. We know that there are 3 times as many red as there are blue. So let's just say there is 1 blue. If there's 3 times as many, that's going to give us 3 to 1 as a ratio. We know that there are 120 in total. Well, the total for the ratio is 4. 120 in total for the question. To get from 4 to 120, I would times by 30. So that's kind of like the magic multiplication that we need. That's going to give us 90 red and 30 blue. A third of red, so a third of 90 were taken by Carl. Now we just need to divide by the bottom, but equally it is a calculator question, so you can just throw it in there and you will get 30. 80% of 30. Again, you can just put that straight into your calculator. You can use the percent symbol and the times sign, or you can find 10%, which is 3, times it up by 8, which is 24. So lots of different ways to process that. So 30 red have gone, 24 blue have gone. So I'm going to take off the 30, take off the 24, and that is going to give me 60 ... 6 for my red and my blue that are left. Okay, so these are what's left. Now it wants the ratio in its simplest form. So we're just going to divide through by 6, and that is going to give us 10.1 as our final answer. Okay, so we need to find the cost of hiring the chainsaw for 6 days. So we are going to go up where it's 6 days, come across and interpret the graph. Okay, that's coming out exactly between 15 and 20. So that is £17.50. Part B is asking us to work out the daily rate. So we can see in the graph that you've got that £10 charge. The rate, the daily rate, comes from looking at a triangle. So finding the gradient of this line. So we're going to use our rise and our run. We can mark the triangle on, which is always quite nice. And it can be any triangle, but I'm going to choose this one here. I know that it's 6 days. I know that 6 days charge is £27.50. Take off the standing charge of 10 and it's £7.50. So I've got 7.5 in this direction. I've got 6 in this direction. It's rise, 7.5 divided by run, 6. Put that in your calculator and you get 1.25. And that's our daily rate, £1.25. Now, part C is talking about a different firm that just charges £3 a day. And we've got to compare these two firms. So what we're going to do is we're going to pop on a rate of £3 a day. So if there are no days, there's no charge. If there's 10 days, 10 threes are 30, there would be a £30 charge. I am going to draw that line, and we can see that this, because this line is under this one here, we can see that the cost is cheaper until we get to 6 days. Then this is more expensive because it's higher, and this is obviously a better value. So we're going to write that down. So words to that effect is really all we need to do there. Again, it's not the only way. I think using the graph makes sense because it's there, but you could also kind of list the charges in a table if you like and compare it that way. Okay, we have a square with length 8.4 and we've got to work out the length of the diagonal. I'm going to put that diagonal in so that I can see it. I could have done it this way, it makes no difference. And I can see that this is a sneaky little Pythag. This edge is also 8.4. My right angle is here. A squared plus B squared equals C squared. You can get that off the formula sheet if you are a student taking their exam in 25, 26 or 27. A and B are the two edges that the right angle points to. And it's a really nice, neat way of just knowing what numbers to put where. So I've got 8.4 squared plus 8.4 squared equaling my diagonal, which is C squared. This gives me 141, and then we just square root to get our final answer. Now, it wants it correct to 3 significant figures, so it means it's going to get cut here, and the 7 is 5 or more to give a final answer of 11.9. Okay, so the diagram shows a circular pond with a path around it. The pond has a radius of 5 and the path has a width of just 1 meter, and we've got to work out the area of the path. Now, what's actually happening here, and I want you to try your best to imagine this. This here is a large circle. So let's draw this large circle. It has a radius all the way to the middle of 6. Now, this very large circle has kind of had a hole punched out of it. So imagine this being just punched out and creating a hole. So this smaller circle with a radius of 5 is punched out. So we want the area, which is pi r squared, of this, take away the area, pi r squared, of this. Now, again, if you are taking your exam in 25, 26, 27, these formulas are on the formula sheet, so you are able to use them. So we've got pi times 6 squared, which is 36 pi, take away pi times 5 squared, which is 25 pi. Now, you can go into decimals at this stage, or you can just leave it in pi. 36 take 25 is 11 pi. You could then put your 11 pi into your calculator, which will give you 34.55, and on it goes. We want 3 sig fig, so count 3 and cut. 5 is big enough to add 1, so we've got 34.6 meters squared as our final answer. Okay, so we've got a right angled triangle and we're being asked to find the angle marked X. So this is a trig, and we have got our formula sheet to help us with that. So do make sure you use it. The formula sheet does not use SOHCAHTOA. It uses A, B, and C. So that's what I'm going to do. Please remember that at the stage of this video being made, it was 2025, 26, 27, where it was guaranteed for that formula sheet to be available. Hopefully, they'll just keep it in place forever. Anyway, the given angle that we have to find, opposite is our A, and then I use the right angle. Once I've got A on one, B is on the other edge that the right angle points to, and this would be my C. I don't need C, it doesn't have any information on it. I would then look at my formula sheet and see which one of sine, cos, or tan has the A and B, and it is tan, and it looks like that on the formula sheet, which works really well with this question. But I would still encourage popping it into the triangle, because if it's a different style question, this can really make a difference and help you see what you need to do. So we've got tan, the capital A is our angle, which we don't know. A is 14, B is 7.5. If I want to know what my angle is, I need to get it on its own. So we're going to move the tan across the equals. So my A or my X, I could have changed to X by now. That's the opposite of tan. Put it in your calculator and then just check to see how they want us to round. It's to the nearest degree. So this would be 62 degrees. Okay, so we've been given some information about area and pressure, and we need to find the force. So we've got our formula. The force has been given as 28 newtons per meter squared, and the area is 1,500 centimeters squared. And this is the first problem, and the first thing we really want to pick up in this question. We have different units, and they cannot be different. We're going to change our centimeters squared into meters squared. So let's just consider the area of a 1 meter square. Both the edges would be 1 meter. Now, if we took that same square and we wrote the equivalent centimeters on and worked that out, 100 times 100, and we can see 1 meter squared, 1 times 1 is 1 meter, 1 meter square is equal to 10,000 centimeters squared. That's our conversion rate. Most people, if they're going to go wrong, are probably going to divide by 100 because there's 100 centimeters in a meter. But we're not talking about the length, we're talking about the area, the space inside. So we are going to have to take our 1,500 in the question, divide it through by our 10,000 to get our area in meters. Now that I've got the same units, I can literally just say, okay, my pressure is 28. That equals the force, which I don't know, divided by an area of 0.15. To work out the force, I just want to multiply through. So 28 times 0.15 gives a final answer of 4.2 newtons. Okay, our last question. We've got a probability tree diagram to complete. We can see information about Kelvin, and we can see that Kelvin is the first person on the tree diagram. So his arriving on time is 0.7. So him being late or not on time would be 0.3. These have to add to 1. And then we've got our 0.9 with 0.1, and that's repeated. Work out the probability they both arrive on time. So this is our on-time pathway. We collect up a 0.7 and a 0.9. You multiply across a tree diagram, and you've got your calculator. So the answer is 0.63. And that is it. So hopefully you have found this paper really useful in preparing for your exams. Stick with us. We are going to be putting a lot of these papers together and online for you.